everyone. Now we will begin about the transport layer. And about this layer, we have two typical protocols. One is TCP and another one is UDP. TCP is a connection-oriented protocol, and it can provide a reliability. And about the UDP, this is a connectionless protocol. And if you want to transfer the packets as soon as possible, we can use UDP. So about this topic, we will focus on the TCP reliable mechanism. That means why TCP can provide reliability. That's because the first one, TCP has a connection before the transmission to establish the connection between source and destination. After transfer the packets, we will delete the connection. And within the transmission, we also have some mechanism like the window. And besides this window mechanism, we also have the other available mechanism to avoid the missing. So this is the part of TCP and UDP. If you are interested, let's begin the topic.
Hello guys, welcome to see this video of the TCP UDP principle. Before we talk about the detail, let's see the practice question of the IP principle. The first one is the natural classification network address corresponding to the IP address 112.1.1 is, and what's the broadcast address? So the correct answer is 112.0.0 of the network address, and the broadcast address is 112.255.255.255. So how to calculate these two addresses? Why we have this question? Because when you do the network planning on your network, you have to delete the network address and the broadcast address because these two addresses cannot be used for the devices, maybe the router, maybe your terminal. So how to calculate these two addresses? The first one, we have to find which classification of the IP address. This address belongs to the range of 1.0.0 to 126.255.255.255. And this is the classification A arrangement. The coverage. And then about the classification A, the network part is 8 bits and the host ID is 24 bits. And then we have to review what means network address, what means broadcast address. The definition is network address make all the host parts to become 0. And the broadcast address is host part to become all 1. So this is the definition. And now we already know which parts belong to the host ID, right? Of the address 112.1.1, the first 8 bits is the network part, and the last 24 bits is the host part. So make the last 24 bits to become all 0. This is a result of network address 112.0.0. And the broadcast address makes the last 24 bits to become all 1. So the result is 112.255.255.255. So this is the first question. And the second one, if now we have an address of 172.15.1.1, we have to calculate how many available host addresses we can use of the natural classification. Of course, the same process, we have to find the network ID part and the host part. So the answer is 6055.34. And how to get the result? First, we have to find the address of 172.15.1.1. This belongs to the coverage of 128.0.0 to 191.255.255.255. And this is classification B, right? And about the classification B, The first 16 bits belong to the network part, and the last 16 bits belong to the host part. And what means the host address? Host address depends on the host ID length. If the host ID length is n, the number of IP address is 2 to the power of n. And what means available IP address? We have to do the calculate of 2 to the power of n and then minus 2, because one is the network address and another one is the broadcast address. These two IP addresses cannot be used for the devices. So now we have to know the host ID is 16 bits, right? So the result is 2 to the power of 16 minus 2, and the result is 65534. So this is the calculation. And the third one, which of the following statements about IP addresses is true? And we have to choose 3 correct answers. And the answer is A, B, and C. That means your option D is wrong. So let's see what's the mistake of the option D. The first octet of the class C IP address starts with 100. So if you forget about the arrangement of class C, you can see the previous video of the IP principle to review again. The first octet of class C IP address starts with 110. And finally, we calculate the range of the class C, 192.0.0 and to the 223.255.255.255. So this is the answers of 3 questions. In the next part, let's see the detail of the transport layer. We say of the OSI reference model, we have 7 layers, and we will focus on 3 layers: the transport layer, network layer, and the data link layer. And we already explained something of the network layer of IP protocol, right? In the data link layer, we will talk something about the Ethernet. And about the transport layer, the typical protocol we usually use is TCP and UDP. About these 2 protocols, we can provide connection-oriented or connectionless service, depends on which protocol you use. Later, I will explain the detail why the TCP can provide the connection-oriented protocol and why the UDP can provide connectionless service. And the next one, the transport layer function is to provide the fragmentation and encapsulation of application layer state. Because the upper layer protocol is application layer. When we receive the application data, we have to do the encapsulation and to become the segment. And the third one, we have to do the implement of multiplexing. So there is a question. For example, now you have the computer, right? And about your computer, normally you only have one IP address and one MAC address. But you can open the YouTube, your Facebook, and your PowerPoint, and maybe Excel at the same time. So how to distinguish different applications? This is the basic function of the transport layer. We can use another parameter we call is port number to indicate different applications in the same hardware devices. So this also is a function of the transport layer. And if you choose the reliable protocol, for example, of the TCP, we can provide the reliable connection and the data transmission. So we have many mechanisms to provide the reliable service. And someone like maintain the connection status, and someone like transmission data reliable, and another one is flow control. So what's maintain the connection and how to establish the connection, and in the transmission, if some data miss or maybe some data is changed by the others, and maybe the capability between the sender and the receiver is not matched, how to solve this problem. And we have many mechanisms to keep the reliable service of the TCP. And this also is a key point of this video. And next part, we see the first function of TCP or UDP. We can provide multiplexing service, right? And we can indicate different service on the same hardware. And how to distinguish different service, we will use a port number. So this one is very important parameter of the transport layer. And let's have a review of the network layer. The typical protocol we will use is IP. And the next layer is the network access layer. We use the protocol of the Ethernet, the PPP frame relay, and so on. And the upper layer is a transport layer of the TCP and UDP. Of course, IP, we will use a protocol number to distinguish different transport layer protocol. For example, we will use a protocol 6 to indicate the TCP, protocol 17 to indicate the UDP. In the upper layer of the transport layer is the application layer. And how to distinguish different applications? We will use a port number. And we have so many different applications. And here I will explain the typical application in our network. And the left part, we will use the TCP to transmit the information. And about the right part, we will use the UDP. And the first one is FTP. FTP, I think if you do some version upgrade or see some other parameters or the other operations, you already know the FTP. The FTP is used to transfer the files. And we have two numbers. One is 20 and another one is 21. One for the net control and one for the control channel and another one for the data channel. So this is the first one. The second one is telnet. And the telnet is used to remote access the devices. So you can have a seat on your office, but you still can do some command on your devices. And one way we can choose a telnet. And the telnet also uses the TCP as a transport layer protocol. And the port number is 23. And another one is HTTP. I think this one is very familiar for you. Maybe you open the YouTube, maybe you open the Facebook, the other URL address. The typical protocol we use is HTTP. The port number is 80. And another one is SSH. SSH also is the remote access devices way, and the port number is 22. And the function is very similar like the telnet, but SSH can provide more security functions than the telnet, because SSH we can do some encryption to help to protect the traffic. And the next one is a DNS. DNS is used to translate the domain name. That's why when you enter the application or you open a URL, you only to remember the name is YouTube. You don't need to remember the IP address like 8.8.8 or the other IP address. That's because our DNS server help us to translate the YouTube to become an IP address. And different applications, maybe some scenario we will use a TCP as the transport layer protocol, and maybe some scenario we will use a UDP. And the port number is 53. And about the right one, we will use the UDP as a transport layer to transfer the packets. And the TFTP, the port number is 69. This protocol also is used to transfer the files. And the radios, the port number we also have two, 18, 12, 18, 13. So these two number, one for the authentication and another one for the account. And about the DHCP, the port number is 67 and 68. DHCP is used to dynamic assign IP address for the client. And the last one is SNMP. The port number is 161, 162. And this is used between devices and the controller. Maybe we want to get some devices parameter like the interface status, the interface IP address, something like this. So between the devices, we have to use the protocol of SNMP. So the left one is TCP. We focus on to transfer the reliable service. We hope we transfer the parameters. Each bit cannot be changed. We can receive the correct message every bit. So about this part, we will choose TCP. About the right part, we hope we can transfer the message as soon as possible. So different service used for different application scenario. And first, let's see the detail of the TCP. Because TCP can provide the reliable service, so we need so many mechanisms to maintain the reliable. And first, let's see the encapsulation. And about the TCP feature, first one, we also use a port number to indicate different applications to provide the multiplexing. About the previous page, right? We explain some detailed applications we use in the TCP. And the second one, because the TCP have to give the reliable service, so the first mechanism is before we transmit the packet to the destination, we have to establish the connection. That means we have to send the message to the receiver. I will begin to send the message to you. Are you existing? Something like this. So this way we call it three-way handshake. And after we establish the connection, we have to keep all the message can be transferred to the destination correct and no bit is wrong. And one mechanism is sequence. Each segment we send to the destination, we will give the sequence number. And about the receiver, we can check something lost or something wrong according to the sequence number. So this is used for the loose detection and out of order rearrangement. And the next one is integrate check. If we receive some message and we can do the error detection. If something is wrong, we can ask the sender to give us a new one again. And the next part is the acknowledgement mechanism. Each part I receive, I will give the reply of the sender. The first three parts I received successfully, but someone lost. Please send me again. This is the acknowledgement mechanism. And the next part is a window mechanism. We can use this one to control the flow. For example, I can send the message to you at the same time, maybe 3 segments, but you cannot deal with this one. So we can do some flow control and to choose the correct ability, and the sender can use and the receiver also can use. So this is the TCP feature. And let's see the encapsulation of the TCP. TCP is Transmission Control Protocol, and when we receive the payload data from application layer, then we will add the TCP header, right? This is the process of encapsulation. After we add the header, this package we call is TCP segment. Do you still remember? I think the first or the second video we say the name of each part, right? After we add the TCP header, this name is TCP segment. And then we will continue to do the encapsulation to add the IP header. And finally, this packet we call is IP packets. So about the TCP header, what's the message we will add into the header? We have so many bits on the TCP, and we will use this message to keep the reliable service from the TCP. That's why we say if you use the TCP to transfer the message, we can promise that every bit is correct, but we have to take more resources than UDP. We have to add more information than UDP, and we also need more resources to do the track. So this also is the disadvantage of the TCP. About this part, I only explain some key points for you. The first 32 bits is very important. 16 bits about the source port and the 16 bits of the destination port. That means when we do the encapsulation, if you use HTTP to transfer the packets, I will use port number to indicate the HTTP, and the destination port also is used to send the receiver to tell you which protocol you have to use to do the de-encapsulation, to deal with the message. And about the source port, pay attention about this part. If on your computer, different server, we will use different number to indicate the server. So this is the first part of the 16 bits source port and 16 bits of destination port. And the next part is 32 bits long of the sequence number, and we will use this part to indicate each segment. And the first one, the number is 1, the second one is 2, something like this. And the receiver will check the information according to the sequence number. And the next part also is 32 bits long about the acknowledgement number. I will give a reply, and this message is correct or not. And how to do the process, I will talk later. And the next part, maybe we can skip the first 4 bits handle length and the receiver. We have very typical one for the 16 bits of the window. And about the window, this is used to negotiate the ability. Can we use this segment number to send the message or not? And the next part is 16 bits long to the checksum, and to use to detect the information is correct or not. And the other one we can skip. So about this part, the key point is the source port number, destination port number, and the sequence number, and some Windows number length long. So this is a TCP header. And then let's see. We say we can give the correct, reliable service for the for customer, right? And the first mechanism is establish three-way handshake to establish the connection. So how to establish the connection and what's the detail of this process? Let's see the next video.